Let R be the region bounded by the graphs x equals negative y squared plus 6y. Okay, that seems right. Kind of like a parabola, but sideways. And x equals 0. Okay. Find the volume of the region R revolved about the x-axis as shown to the right. Okay, so we have this delta y, and we have a rotation here. And this is going to be the shell method. So you have the disk method where you basically make a whole bunch of disks and just stack them on top of each other. And then you have the shell method where you have a whole bunch of concentric shells. So the idea here then is we're going to have a shell. I'll do it kind of like this. Like this. It's a terrible shell. That's like a shell. And then we'll have another shell on top of that. And these shells will be of a thickness of delta y. And so the idea is we will measure the thickness of each of these, or the volume of each of these shells, and then add all of the volumes together. And so the way we're going to do this then, so you can see that this is kind of like the shell right here. And so the volume of a shell will be 2 pi r, where r is the radius from the center to the shell, times the height of the shell, and then in this case will be times the width of the shell. And your thought process might be like, well, what's the radius? Is the radius the inner radius or the outer radius? So the inner radius might be r, but then the outer radius would be r plus delta y. Well, the idea is these are infinitely thin shells, and we have an infinite number of them, so calculus. The idea is when we take delta y to be very, very small, we get an approximation of the volume of the shell. And when we get an infinitely good approximation by making delta y infinitely small, then we're going to get an infinitely accurate answer, which will be exactly accurate. And that's kind of the idea behind calculus. If you get an infinitely good approximation, then that is the exact answer. So we're going to work through this using the shell method. So this is the formula you will pretty much always use. 2 pi r, which is this radius right here, or this circumference right there, times the height right here, and delta y will then be your delta y. And so now we need to find out what each of these correlate to. So r will just equal y. We will start at 0 and go to whatever this value is, right there. And since it's a circle, it'll go out in both directions. So we don't have to do from top to bottom. We'll do from middle to top. And we'll find out what that is in a bit. And then h would be the height of these shells or cylinders. And that will be this value right here, which we're given is negative y squared plus 6y. Okay? And so now we need to find out the final y value. Okay, we can do this. So the y value, this is where x equals 0. And so if we have x equals negative y squared plus 6y, we're going to say that equals 0. So then setting it equals 0, rearranging things, we get y squared minus 6y equals 0. We already know we can factor out a y, and we have y minus 6 equals 0. Get rid of one of the y's. I know you have to be careful about dividing by 0, but such is life. We'd find out that y equals 6 is a possible solution. So this value right there will be 6. If we plug in 6 to this, we'll get another 0. So we will be evaluating, yep, I'll delete those, from 0 to 6. Okay, now we plug everything in and do the calculus and probably do the algebra. 0 to 6, move out to 2 pi because it's a constant, we can just pull that out. R is y, and then we have the height, which is negative y squared plus 6y, and then the delta y, as it becomes infinitely small, will become dy. Okay, so we still have the 2 pi, we have an integral, we have a negative y cubed plus 6y squared dy, which is fine. Now we can do the power rule. which is negative y to the fourth over 4, little bracket there, plus 6y cubed over 3, 0 to 6, get my cancellation color, which makes this 2, but then I'll leave the 2 pi on the outside, okay? So both of these have y in it, so when we plug in 0, we will get 0. And we will then have 2 pi negative 6 to the fourth. So this will be, I'm going to say negative 36 times 36, because I don't know what 6 to the fourth is, but I can probably sort of do maybe each of them half together. So each of those is 6 squared. Plus 2 times 36 times 6, okay? We have 2 pi, so I'll get my canceling color again. Turns out my canceling color is just a different color. So this will be 9. 9 times 36. 36 times 9, 54. 9 times 6 is 54. I'll do that 4 a little bit better. 9 times 3 is 27. 27 plus 5 is 32. 324. Okay? Negative 324. Seems like a big number. Let's see, 10 times 36 is 360. So yeah, maybe, possibly. Okay, so 36 times 12. Nope, I'm going to do 72 times 6. That way I can do one digit. 6 times 2 is 12. Is it 12? It's 12. I'm pretty sure it's 12. 6 times 7 is 42. But plus 1 is 43, 432. Plus 432. So now we're going to have to do 432 minus 324. 2, 1, 8, 0, 1. 108. Okay. So we have 108 times 2, which is 216. 216 pi. That seems awfully square. Aha, it's even a possible answer. Interesting. Interesting. Okay. So, the answer to this then will be, that's a lot of pi. Okay. But I guess it's a big parabola. Backtrack. Overview. Let R be the region bounded by the graphs of this. Okay. So what we did was, we had the graph. It was drawn for us, but if it wasn't, we'd want to draw it just to kind of see what's going on. We figured out the endpoints here by solving for x equals 0, 0 to 6. We then wanted to use the shell method because usually it's easier just to visualize and see, all right, is it easier to do a whole bunch of concentric shells, or is it easier to stack a whole bunch of disks? Sometimes either way will work. This one, it looked like it was strongly hinting at the shell method because they gave us an axis rotation in this way, and they drew a little delta y there. So I didn't even really consider the disk method. I'm pretty sure it'd work. And I guess it'd actually be the washer method, the disk minus disk method. So our formula for the shell method is we make a shell, 2 pi r, which is the circumference, times the height of our shell, which gives us a cylinder, a hollow cylinder. And then we multiply that by delta y to give a thickness to the wall of our shell. We then plug in our values. In this case, the radius of the shell is y, and the height of it will be negative y squared plus 6y. And that then gave us the values for our shell method. We plug them in. We do some calculus. This was just the power rule. Actual calculus part wasn't too bad. And from there then, we did a bunch of algebra, did some math, and no division, just multiplication, and came up with an answer. And our answer was 216 pi. This is actually a volume. So that was how we approached this problem. That's how we solved this problem. Thank you much, and I will see you on the next one.